Okay, so kinetic energy, as earlier stated in the presentation, the dictionary definition states energy which a body possesses by virtue of being in motion, or you could just say, by more simply stating, it's the energy of things that are physically in motion. And here are some examples. So here you have like one of those little things that you can win at Dave and Buster's where you drop the ball and then everything moves and it just constantly moves. That would be an example when the balls move of kinetic energy. And then here, put it a little closer, as she's holding the ball up right there, this would be potential energy. But as she drops the ball, it turns into kinetic energy, which you there see. And there are 5 types of kinetic energy, which are mechanical, electrical, thermal, radiant, and sound. Basically, mechanical is literally the most obvious. It's mechanical, you can see it. Electrical is the negative flow of electrons, also known as electricity. And thermal is the activity among atoms and electrons that cause warmth, which is kind of like radiant, but there's a difference. And then radiant would be the energy traveling through waves, which causes heat. So yeah, thermal is the activity among atoms and electrons, while radiant is the energy traveling through waves, which causes heat. And then sound would be the energy that humans can hear with their ears through waves also. And here are some examples of kinetic energy. So here you have mechanical, which would be the obvious of them swinging and hitting, which would be mechanical energy. Here you have electrical, another type of kinetic energy, where you can see the flow of electrons flow from the light bulb to the battery, which powers the light bulb. And then here you have thermal energy. Right here you can see it traveling, which causes warmth, which causes it to cook. And then here you have radiant energy, which is a kind of here like thermal, except it travels through radiation waves. And an example of that could be the sun, and then the waves going to Earth. And then here you have sound, which you'd be using mechanical energy to play the guitar, but what comes from the guitar would be sound waves, which is a type of kinetic energy. And then we have conservation of energy, which, here we go again, the definition states is the law of conservation of energy states that the total energy of an isolated system remains constant. It is said to be conserved over time. This concept comes from the first of 3 rules of thermodynamics, which, again, more simply stated, just means energy cannot be created or destroyed. It simply just exists and can transform or go over from one form to another. And here's an example of conservation of energy. When you throw a football, the potential energy doesn't just disappear. It transforms into the kinetic energy of the ball. And here you have Aaron Rodgers, who has potential energy of throwing the ball, but when he throws it, it turns to kinetic. So energy doesn't leave, it just transfers from one form to another.